Okay, it says we're live. Okay, so a couple of things. Number one, I'm pretty sure, I need to share my screen. I'm pretty sure that I posted the link on Canvas. We're about to find out for my YouTube channel. You stupid. Have you noticed that if you let that login screen sit there for a minute, it will not let you log in, period? It's really annoying. Okay, so if you go to announcements, and if it's not there, I will post it right now. That's why I'm doing this. But I believe videos and homework, the very first announcement there, if you click on that, that will take you to my playlist for all of the YouTube videos. And yeah, so chapter 10, I think, yeah, so that's everything. I forgot that. No, that's what we did last time. Yeah, so I will add this video. So just click on that link. You don't need a YouTube account to watch, but if you subscribe, then you'll be notified as soon as I post it, which is probably right after class. Okay? So hopefully I did that already, but we'll see. Okay, so that's the link there. That's the very first announcement. Second announcement. It's time for a test, right? You guys don't want to have a final exam with no test, right? You're like, well, we'd rather not have any tests either. But, so I'm thinking probably next Tuesday, a week from today, we will meet in our regular classroom for the test. Now, the testing center, so we'll do the written test in our regular classroom. I don't even remember what room that was. Do you guys remember? 214. Okay, we'll go back to 214 for our test next Tuesday, and then we will. So I will also probably put the test at the testing center. You can spend as much time on the computer portion as you want, but if you want to spend 10 hours there, you got to get there early. Okay. So the test in the testing center, I will let you know for sure on Thursday, but I'm pretty sure it'll probably be Monday through Wednesday, which means I won't have that graded in time for Thursday when I pass back, but I'll have your written stuff back by Thursday. Okay. So so I don't want to give you too much, or then you'll be like, I can't remember all this stuff. And so we'll stop after chapter 4. We'll probably, if we don't finish chapter 4 today, we'll finish it Thursday, and then we'll do a review with whatever time we have left. Yes?
And then, do you make study guides or anything, or is it just like?
I haven't made a study guide. I will see if I can come up with some. Do you know how to do this? I mean, the great study guide is review your homework, review the quizzes, and if you do pretty well on that, then you should be okay. Yes.
Is it going to be on chapters 9, 10, and then 1 through 4 as well?
That's correct. 9, 10, and 1 through 4. So that's 9, 10, and 4. That's 5 chapters. That's pretty good. Okay. All right. Any other questions about that? Okay. So it's on recording. You can't say I didn't tell you. It's on, we've got video evidence. Okay. All right. So it'll be a 2-part test. Tuesday in class, LA 214, written, and then in the testing center. If you take it on Monday, I'm pretty sure that's the day I'll open it up. It's free, but if you take it Tuesday or Wednesday, you have to pay $4. Okay. So there's your incentive to take it early. All right. Okay. So Gentry had a great question before we started recording, and she says, well, how do you find information when it's not on the 68, 95, 99 rule, right? Okay, so that's a great question, and how you find that, let me make sure I'm recording this properly. Let's stop my screen share. Stop. There we go. Okay. So any normal distribution can be converted to, and I'm going to underline the word standard, because a lot of times people ignore that word, and that's a very important word, normal distribution with the equation z equals x minus mu over sigma. Okay? That's the formula in the book. Now, in a few chapters, I'm going to teach you a new formula that's going to look very similar, and you're going to ask me which formula you're supposed to use because they're so similar. So I'm just going to give it to you now. Z equals x bar minus mu over sigma over the square root of m. Okay? Notice those formulas are so similar. Okay? This is the better way. Okay? So here's what I'm going to give you. If you use this one all the time, you'll get it right. Okay? This is the one they give you in the book. So here's the rule on how to decide. If they give you n, meaning the sample size, use it. If they give you the sample size, use it. If not, assume n equals 1. Now let me ask you a question. If n equals 1, what's the square root of 1? 1. So that goes away, and it becomes this exact same equation. Okay? This is the one that they give you because in this chapter, n is always 1. Okay? But if you'll remember this one, and just know that in this chapter, n is always 1, then you won't ever ask me, well, I don't know which equation to use. Because these are so similar, just use this one all the time, and then you won't have to wonder which one to use. Okay?
Is this 3.5?
This is 3.5. Okay?
Is x bar all of the points?
So x bar, I'm going to treat x bar and x. X bar is actually the mean, but I'm going to treat them the same for this. Okay? All right. So another way to think of this equation is the data minus the mean over the standard deviation over the square root of n. So conceptually, that's what's going on. Okay? So, I wish this board was a little bigger. All right, so let's give you an example here. Okay? Let's say all right. SAT scores have a mean of 600 and standard deviation of 100. ACT scores have a mean of 18 and a standard deviation of 6. I'm going to pick on some people like Eddie. Eddie scores 21 on the ACT, and we're going to pick on JC. Scores a 600, no, sorry, this is a 500. JC scores 600 on the SAT. Who did better? Okay, so I changed that to a 500, sorry. Okay, so Eddie, okay, now both Eddie and JC, you know that ACT, SAT are college admission tests, right? We're assuming they're both normally distributed. So we're assuming they're normally distributed. I probably should have told you that. Okay? And so you guys know they're both college admissions tests. You know that they're scored very differently. So we want to figure out, oh, I probably should talk about the standard normal distribution. Okay. I'm not going to pick on you just yet. Okay? But we should talk about the standard normal distribution. I started talking about it, then I got carried away with this. Oh, I have enough room. Here, we'll do it here. Okay. So these are two different normal distributions. One has a mean of 500, one has a mean of 18. Okay. We're going to convert these normal distributions to a standard normal distribution. The standard normal distribution has a mean of 0. Okay. Mu is always going to equal 0 on the standard normal distribution, and your standard deviation is always going to be 1. Okay? Always, always, always. Okay? Just don't forget that word. If it's a standard normal distribution, the mean is 0, the standard deviation is 1. Okay? All right, so what we're going to do is we're going to take Eddie's ACT score, and we're going to convert it to a standard normal distribution. So I need to find the z-score for Eddie. Can you help me do that? Yeah, and okay. This might be helpful.
If I can see.
Oh.
So you take the data, which is, I guess, my ACT score.
Okay.
So
Which is
21.
21.
Then subtract that by the mean.
Which is 18. And divide that by
The standard deviation, which is 6.
6.
And
And how many Eddies are there? There's only one Eddie. Okay, we're going to divide that by the square root of 1, right? So 21 minus 18 is
21 minus 8 is
3. And 6 divided by the square root of 1?
or
So yeah, so that works out to be 1/2, or if I convert that to a decimal of 0.5. So under the 68, 95, 99 rule, you are about 1/2 of a standard deviation above the mean. Okay, so I'm going to put an E for Eddie there. Okay, now JC, can you figure out? Here, we'll do yours over here. JC, I'm trying to see if I've got room on my camera. Okay, JC, can you figure out your z-score?
So mine is going to be 500.
500. Is that your score?
Sorry, what was my, I got them mixed up. My score, I wrote it down here. My score is 600.
Your score is 600.
600.
600 minus,
Mine is the mean of 500.
the mean is 500.
Divided by the standard deviation, 100.
Which is 100.
Divided
And how
by
many JCs are there?
just one.
There's only one JC. Okay, so 600 minus 500 is 100. And 100 divided by the square root of 1? 100. So that's 1. Okay, so you're actually right at, in fact, you're right at this value. This is the, you're right here on here. Okay? So who did better on this test? JC did better. Sorry, Eddie. She beat you.
almost second best.
No, you're not.
All right, so JC did better. Now the next question is, well, we'll stick with JC for a minute. How did she compare to the nation? Okay. Now the interesting thing about JC is she's right on one of our borderlines here, right? We know that 68% of students scored between -1 and +1, right? We know that that's 68%. How much is in this area over here? 16%. So if I add the 16% plus the 68%, how many people did she beat? Yeah, so JC is in the 84th percentile. I can't spell. Okay? She did better than 84% of the students. Okay? Now that was nice because she ended up right on one of our rules for the 68, 95, 99 rule, right? Now the question is, Eddie didn't land on there, right? So how do we figure that out? That was your question, wasn't it? Okay? So here's how we figure that out. In the back of your book, there's a table A. So go ahead and look at that. For some reason, they put it on 2 pages. It looks like this. For those of you here on camera, it looks like that. It's in the very back page of your book. However, I have this Excel sheet that I'm going to show you, and I'm probably going to share this. But it fits on a single page, okay? But it works exactly the same way. I like this better because I can scroll, and I think you'll be able to see it a little bit better. But it works exactly the same as what's in your book, okay? Now, the first thing that I want to mention to you is to notice the picture. Notice the blue area here is highlighted, okay? So what it's telling you is, it's telling you the area of the blue area, okay? Now, in Eddie's case, Eddie got 0.5, okay? So I've got a Z, so these are your Z-scores down here, and Eddie got 0.5. So I'm going to go down here to 0.5. He's got 0.50. So you can think of this is your first decimal, and then these columns are your second decimal. So if let's say he got a Z-score of 0.55, I would go over to this column here, okay? Now he got 0.50, so he's right here at 0.6915, okay? So what that's telling me is, if I go back to my board here, stop sharing. Come on, I hate this thing sometimes. Okay, well, I'm going to pick a different color here, like red. Okay, so Eddie, this area here in red is 0.6915. Okay, so Eddie scored better than 69% of students. He didn't do as well as JC, but he did better than more than 2/3 of the students out there. Does that make sense? Okay, so that's how you're going to read that table. So you're going to want to use the one either in the back of the book, or I may post this on there because it's on a single page. I will probably, you have to memorize that table. No, you don't, I'm just kidding. You do not have to memorize that, I'm just kidding, okay? So I'm going to give you a formula sheet, and I will give you probably this table here that I just showed you, or the one in the back of the book, but they should work exactly the same, okay?
Are we going to use that on the test?
So you can use this on the test. You don't have to memorize this. Okay? I'm not that mean. I'm not that mean. Okay? All right. So let's do another example here. Let's see what I've got here. Question. Keaton, right?
Yeah. So couldn't you just do like 3/4 of like a full standard deviation? So like multiply 68% by like 0.75.
Oh, okay, so the question is, couldn't you just say, can I just do half of that, half of the 68%?
Yeah.
No.
No, not half of that. So 68% goes from -1 to 1, correct?
Mm-hmm.
And so 0.5 is, if you take 0.5 out of that, then you would get 3/4.
Okay, so he's saying, well, if I put 0.5, that's like 3/4 of that area.
Yeah, so if you support 68%.
Okay.
And then
Now, let me just stop you. The reason why you cannot do that is because this is a curve. If it was a straight line, you could do that.
You could do that.
But because this is a curve, it's going to foul you out.
Yeah, that's what I'm wondering.
Yeah. So that's why you should use the table. Okay? The table will be very, very accurate. By the way, usually what I do when I introduce this table is I tell you that in order to calculate this area, you have to do calculus. And then people freak out and go running out of the room. No, I'm just kidding. So anyway, I didn't do that today. I didn't scare you guys. But yeah, this table comes from calculus. So you don't have to know calculus to use this table though. Okay? Yes?
This table only works on bell curves?
Only works on bell curves. And by the way, let me just mention this really quickly. This spreadsheet I have, I think we're gonna learn the t-distribution. Notice that t-distribution also looks like a bell curve, and it gives the shaded area to the right, not to the left, as this one does. And so we probably are gonna learn the t-distribution later on. So make sure that when you're doing your numbers, that you're paying attention to what is shaded. Is it the left side or the right side? Okay. So let's do another example here. I'm going to open up a new spreadsheet here. Okay. All right. So let's say that toddlers have a mean height of 38.72 inches with a standard deviation of 3.17 inches. Okay. This is normally distributed. Find the probability that a toddler is 35 to 38 inches tall. Okay? Now, I can't remember if I've introduced this phrase to you. I don't know if I have. Have you ever heard of WWRD? I don't think I've heard. Have you ever heard of WWJD? What would Jesus do? What do you think WWRD stands for? What would Rick do? Okay? You know what the answer to that question should always be? Draw a picture. Okay? Rick would always draw a picture. So here's what I'm going to do. Let's stop sharing for a moment. Okay? Okay, so I can erase something here. You've all got this z-score memorized, right? You got it written down, look at it, okay, if you need to. Okay, so according to my problem here, okay, we're going to do the bell curve for toddlers, okay? So I'm going to draw a bell curve. You should get really good at this. If you want to get the problem right, this is what you're going to want to do, okay? So, Gentry, I got it, okay? What's the mean of a toddler? 38.72 inches. And what do I want to know? Standard deviation is 3.17. So if I add 3, I'm just going to round that to 41 and 35, right? For now. That's close enough for what I'm doing. Okay? All right, I want to know how tall these toddlers are, right? So 38 would be about right here, and 35 would be about right here. I want to find this area here. Okay? That's the area. That's the probability that I want to find that area. Okay? So, how would I do such a thing? Robert, what do you think?
Well, you can find the percentage using 65 or 68, 95.
Well, that's not really on the borderline, though, is it?
No,
No.
close.
Close, but we want to be exactly right. We want to be close. Any ideas? Get an idea, Keaton?
Would you subtract the standard deviation?
Subtract the standard deviation from the mean. Well, that's kind of what I did here, but I want to be more accurate than that. Okay, the hint is I just erased the equation you're going to want.
Data and subtract mean or standard deviation.
Yeah. Z equals x minus mu over sigma over the square root of n, right? That's the equation you're going to want. Okay? So let's find the z-score for the 38, and let's find the z-score for the 35. Okay? So Olivia, can you help me find the z-score for the 38?
Yeah, so Z equals, we get 38 minus 3.17.
What's the mean?
Oh, 38.7.
38.72 divided by the standard deviation, which is 3.17, divided by the square root of, did it give you an n? So what do you assume? 1. Okay? We'll do, you guys, somebody can figure what that out is in a minute. Dayla, can you find the z-score for the 35?
Yeah, so it's 35 minus 38.72 over 3.17 divided by square root of 1.
Okay, so this is going to be negative 3.72 over 3.17. This is going to be negative 0.72 divided by 3.17. Okay, so I do want you to do this both with the calculator correctly and with the computer. So we're going to transfer this over, but that's basically the work that we've done, okay? Okay, so if I go back to here, so I need to find the z-score for the 38. We'll do that one first. That's going to be 38 minus 38.72 and equals 3.17 divided by 1, whatever, that's done. Okay, so that's going to give me a z-score. That divided by that equals negative 0.227.
Do that again. I looked down for like a second.
Okay, so I'm just doing the numerator. Equals, the numerator's 38 minus 38.72.
Okay.
Okay, and then I just did the square root of 1 in my head. Equals 3.17 divided by, I just put 1. Okay, and then I said, take the numerator, divide it by the denominator, and I got 0.227. Okay, in the back, what's your name? Carson. Can you help me do the z-score for the 35? Equals 35 minus 38.72. And 3.17 divided by 1 is still 3.17. I take my numerator, divide by the denominator, and I get negative 1.1735. Okay? Now what? What do I do with those values?
Take them to the chart.
We're going to look them up on the chart. Z-score, okay? This is the z-score, and this is the z-score, okay? So I'm going to look up, and I'll round that to negative 0.23. So on the chart, I'm looking up negative 0.23. So on the chart here, okay? This is why I like this chart, because this thing's still here. So what value should I get for negative 0.23? So negative 0.2, so I'm on this row, and I'm in this column, and that's the value there, right? So 0.4090. So on the chart, I get 0.4090. And now I need to look up negative 1.17. What value should I get there? What'd you say? No, that's not correct.
So 1 is -0.
Negative 1.1. So I'm on this row here, right? And then I'm in this column here. So I should get 0.1210 right there, right? So 0.1210. Okay, now let's remind myself what this chart is telling me. Chart's telling me everything to the left. So I've got, this is to the left. So I've got about 40% to the left, and I've got 12% to the left of that. So how do I find the probability that a toddler is 35 to 38 inches tall? By the way, these are called p-values. I'm going to call those p-values. Okay? Okay, let's go back to my picture. Let's make sure we understand what's going on. Okay, so if I go back to my picture, okay, what we've done here is I've said that I've got 0.4090 to the left of 38, excuse me, of plane of 38. Okay, and I've got 0.1210 to the left of 35. How do I find this area here, given these two numbers? Subtract them. Okay, so 0, 0, 8, and that was 8, 10 minus 2 is 8. 3 minus 1 is 2. So a little more than 1/4, about 28%, almost 29% of toddlers should be 35 to 38 inches tall. Does that make sense? I just subtracted the p-values. Don't subtract the z-score. Sometimes people subtract the z-scores. That was negative 0.23, and this was negative 1.17, right? Don't subtract the z-scores. Subtract the p-values. Okay? So that's the answer there. Okay? Now let me ask you another question. Do you think Excel can figure this out?
Yes.
Okay, so here's the rule. On Thursday's quiz, I'm going to have you do it on the chart. And on next week's test, I'm going to have you do it on the computer. Okay, so here's how you do it on the computer. Okay, oh, I hate this thing. Okay, so the chart says subtract. I'm going to take the top number minus the smaller number. So I get 0.288. Okay? So that's the answer right there. Now, if I want to do this with the computer is actually going to be more accurate. The computer works exactly the same way that the chart does. Okay? Now, there's a couple of different commands I can use. I'm going to give you guys the easy one. Okay? The easy one is norm sdist with no periods. There's another one that has periods. You'll get the same answer, but this one's the easier one to use. Okay? So if I use norm sdist, then it's asking for the z-score. Well, the z-score was negative 0.227. Okay? And the nice thing is I don't have to round. So I'm going to leave that there. Okay? The chart gave me a value of 0.409. This gives me a value of 0.410. So very close, right? Very close, but more accurate. Can you help me do that? I haven't picked on you yet. What's your name? Sydney? What's the command I use? Norm sdist. What do you think the S stands for? Standard distribution. Okay, this is the standard normal distribution. What am I clicking on? This number here, negative 1.17. On the chart, it gave me 0.1210. I got 0.1202, so that one's a little bit more off. Okay? I'm still going to subtract. So I'll take the bigger number minus the smaller number. So I get 0.2898. So my answers are going to be off a little bit, but which one's the more accurate? Computer, because I'm using more decimals, okay? Plus it's a computer. Okay? All right, do you think you guys are going to be able to do that? All right. Okay, here's another question. How tall are the middle 90% of toddlers? That's a good question, right? Okay, I'm going to stop sharing for a minute. We're going to go back to my video. Okay. All right. Okay, so who picked on you yet? What's your name?
Jordan.
Jordan. Help me draw a normal curve. What's this value here?
The mean.
That's the mean, and the mean toddler size is
38.72
38.72 inches. Okay? And I want this area here to be 90%. Right? So I've got to figure out what these two numbers are. Okay? If I've got 90% here, how much is in the tails? You got 5% in this tail, and you got 5% in this tail. Now, my chart tells me what's to the left. Okay? So what value should I be looking for? Okay, so I'm going to look up 5% on my chart. Okay? Now, here's the deal. I'm going to be using my chart backwards. Okay? So I'm going to be using it the opposite way of what we just did. Okay? So if I go to my chart here, where's my chart? Okay, here's my chart. Now remember, these values here in the middle are the percentages. So I need to look up 5%. So 5 was 2, 3, 4, 5. Okay, so where's 5% on here? Oh, so 5%, do you see how it's right smack dab in the middle of those two numbers? Okay, so this is where, when you get here, I'll split the difference, okay? So the value here is negative 1.6, and then it's in between those two values, right? So I'll split the difference in this case, since it's smack dab, 5% is smack dab in the middle of those two numbers, okay? So that gives me negative 1.645, okay? So if let me go back to here for a second. Stop sharing, okay? So if I convert this regular normal distribution to a standard normal distribution, what is the mean, what is the mean of the standard normal distribution? You're lost, okay? Beginning of class, I said the mean of the standard normal distribution is not 1, it's 0. Do you remember that? You don't remember that? Okay. So at the standard was a key word. Remember, I boxed it. Erase now. It's not there anymore. I erased this out of your mind, right? Okay, so the mean is 0. So what I'm going to do is I'm going to convert 38.72 to be the new 0. Okay? And what's the standard deviation of the standard normal distribution? 1. Okay? So that's 1. That's going to be minus 1. Okay? Now, this is if you add 3.17 and if you subtract 3.17, that'll give you what those values are. That's about 35 and that's about 41, roughly. Okay, you remember that from today's quiz? Now, the idea here is I want 5% in this tail. When I look it up on the chart, I got negative 1.645. That's what this value is here. That'll give me 5% in the tail. Does that make sense? Okay. I'm still going to use this same equation. Okay. But now I'm going to solve for x. Okay. So I've got negative 1.645 equals x minus mu. What's mu? The mean. What's the mean?
0.
Well, it is 0 on the standard normal. What is it on the regular normal? It's 38.72. So I'm using the standard normal to get back to the regular normal. Okay? So that means I've got to use these numbers. Divided by, what's the standard deviation? 3.17. Do I have an n in there? No, so I assume it is 1, square root of 1. Okay? Now I need to solve for x. Okay? That's going to go away because the square root of 1 is just 1, right? So how do I solve for x? I haven't picked on you. Yes.
I do have one question. How, like,
Tell me your name first. Catherine. Cat. You go by Cat?
yeah.
Okay.
So like when you're trying to solve, it's like a regular normal, or like the standard normal, how do you so like in a problem? Like,
Okay, so the standard normal is this chart. Okay? The regular normal is everything else. Okay? I'm going to use this chart to convert back and forth. Okay? And so that's exactly what I'm doing. I'm using the standard normal to convert it back to whatever the toddler sizes are, because that's what I want to know. Okay? So I want to figure out what 1.645 is on my regular normal.
How did you get that 1 point? Did you just keep?
How did I get the 1.645? Okay, let me show you how I did that.
The chart.
Okay, so I went to the chart. I want 5% in the tail, right? Because I want 90% in the middle, so I want 5% in each tail.
Yes, so then we got it.
Okay? So I look up 5% in here. There is no 5%, but that's the closest I'm going to get right there. Okay? So that gives me a z-score of negative 1.6. And since it's right smack dab in the middle of those two, that's where I got those 4 or 5.
Ah, okay.
Okay? Now, if I was closer to one end or the other, I would just pick it. But since that's like smack dab in the middle, I'll split the difference. Okay? Yeah. So I'm using the chart backwards. Okay? Backwards from the way I just showed you. I look for the 5%, I get the z-score, negative 1.645. Okay? All right, so now I'm going to go back here and I'm going to use this chart backwards. Okay, so solve for x. How do I solve for x? Multiply by 3.17. So that will cancel that, times 3.17. And then I'm going to add 38.72. So x equals negative 1.645 times 3.17 plus 38.72. Okay? All right, so now I'm just going to use my best calculator ever. Okay, so the middle 90%, so I'm going to use 3.17 times negative 1.645 plus 38.72. Okay, so that tells me that this number here, let me share with my screen here. Stop sharing. This number here is whatever I just said. 33.5. This number here is 33.505 inches. Okay? Now, how do I find this number? What percent is to the left of that number? 95% now, because I've got this 5 plus that 90, so that's 95%. Okay, so now I need to look it up on the chart. So if I look up 95% on the chart, let's see, 97, 96, 95, 90, oh, so it's right in between there. Okay, so this value here is positive 1.645. Okay, so this is positive 1.645. Okay, so now all I have to do is, this is basically the same equation except for I make that a positive, right? So now it's positive 1.645 times 3.17 plus 38.72 equals x. And that is running off the board. But here's what I'm going to do. I'm going to share my screen. I hate this sometimes. Okay, I'm going to copy that exact formula. But this time I'm going to make that negative a positive. And I'm going to get 43.93 inches. So this value here is 43.93. Okay, so the middle 90% of toddlers are 33.5 to almost 44 inches tall. Okay, we didn't get to cover any of chapter 4 today. I think we'll probably just do a review. You guys only want to cover that many chapters anyway, right? Okay. All right, so here's what I'm going to do. I'm going to make a review next time. So finish off the rest of chapter 3. Okay. And we'll just make next time a review, and then we'll have a test. Okay, so it's going to be chapters 9, 10, 1, 2, and 3. Okay?
But we're only reviewing next time.
We're going to only review. So make sure, bring your questions. So it'll be this, it'll be everything. We're going to cover everything for the review. Okay?
Oh, we don't
So
have a test, a quiz.
we will have a quiz on the rest of chapter 3, and then it'll be review the rest of
Okay, so
it.
this stuff.
This stuff.
Okay, and then you're posting this.
And this, yeah, this video is going to be posted.
Will this Excel sheet be posted on campus?
I can post that if you want, like it. Sure.
And where's the chart in the back of the book? You don't page one.
It's literally, it's not, it's like, go back one page.
Well, I have, it's the online one. Can you just open this?
Sorry. I will try to I will try to post my thing as well. But yeah, this is what you'll use for your homework. And my chart's exactly the same, it's just better.
So you can't count on like just subtracting the mean of this. And
Yeah,
then,
don't subtract your z-scores, don't subtract your
and then
means, you
add
have
it
to
because
convert
it's
it.
not equal.
Yeah, because it's a big curve.
Yeah, because it's not equal that way and that way.
Yeah, if it was a straight line, you could do that. But since
So I was thinking, because it's pretty close, like you got 5.2 at 5.2, about 43.9.
yeah, I mean, it's a good estimate, but this is going to be more accurate.
That's what I was.
Okay. All right, thanks.